Consider this my resume for applying for Associate Professor of Electrical Engineering at your place of learning. I am not formally trained. I have been training myself on various simulators for the past 6 years, taking the position that experience is superior to knowledge, knowing that eventually I would understand what I was doing, but it would take longer and be more difficult than actually being successful at what I was attempting to do, which was create over unity. Now, I know what you're going to say or think, but I'm going to say my little monologue in defiance of what you think and in support of what I think to explain my success. Now, the first thing off the bat is the contention that computers have round-off error, and this is a very real problem. I deal with it, and it gives me a lot of false positives, but it is not the last word on the subject of trumping or wiping aside or the notion of over unity. But let's deal with it. So when I switched over to 64-bit computers, it changed everything, and it made it more challenging to come up with over unity, but it did not make it impossible. Now there's another situation that I need to deal with, and that is the presumption upon physicists that is imposed upon electrical engineers that there's no such thing as a free lunch, you can't get more energy out than energy going in, and so it becomes a self-fulfilling proposition, and my argument is in two parts. The first part is to say that because we take this presumption as a matter of fact, we then proceed to make it fulfilled by calculating how much energy is required by the load, and we add a little extra to cover our losses, our projected losses, and then we feed that massive amounts of energy in the form of voltage and adequate amp hours to our circuit, suppressing overreactance, which is qualified by Foster's reactance theorem to be negative impedance. We literally suppress negative impedance, because if we do what I have learned to do, never give a circuit more than what the environment possesses, namely a microvolt, more or less, enough to power a crystal radio set from 100 years ago, then the situation changes. Because when we force feed a circuit the entire quantity plus a little extra of energy that it'll require to run, we are sending energy to the circuit. But when we do not send energy to the circuit and we simply allow the circuit to listen to its environment as to the available energy that's already there, now instead of sending energy to the circuit is listening or receiving. It becomes receptive to the stimulus, acting as a catalyst, not as a source of energy, but as a catalyst to stimulate overreactance if the circuit is properly engineered to perform that feat under that condition of starvation, namely a microvolt, instead of a microvolt, and for that matter a microamp amounting to nano or pico watts. And yet it is possible to come up with any quantity of energy, but I'm getting to that. I'm getting ahead of myself. So we have to encourage overreactance. We have to encourage negative impedance, and the first step is to starve the circuit, but not cut off feeding it energy entirely, but encourage it to acquire an energy level similar to its environment. Now, we can either plug into the environment, such as with grounding rods, or grounding apparatus that are geared to grounding to the atmospheric field, regardless, or my favorite is to pre-charge a capacitor with a microvolt, or to use a, let's say, a solar panel or a battery, preferably a solar panel, or a whip antenna, or some kind of DC voltage source, because under simulation that's what I end up using, regardless of how I imagine it to be in the real world. a DC voltage source supplying, let's say, 1.5 volts or 3 volts or whatever. So, like a little AA battery. And then there's a voltage division and or current division immediately between it and the circuit to bleed off excess energy to ground. And meanwhile, the voltage source supplying this mere meager voltage has its tail end, one of its ends, let's say the negative terminal, going to a ground of its own. And so it only has one terminal connected to the circuit. And even that splits off, forks to ground with various resistors to create a loss of wattage, a tremendous loss, so that the circuit never gets more than mere nanowatts or picowatts. This is very important. No more than, let's say, a microvolt or a microamp, depending on whether it was current division or voltage division, to bleed off the excess energy. So this is the first ground rule, is to starve the circuit, but not entirely. You give it enough to tease. You tease the circuit. You tease the negative impedance to come to life if the circuit is properly engineered for that to occur. It has to be arranged for that to occur, but you also have to tease it to occur and not suppress it. Let's see. The next step is to deal with this conservation of energy business. Conservation of now there are two predicates I have to undermine, and this is one of them. Well, actually, three. I just covered one already. Don't suppress negative impedance. Okay. Sorry, I don't have an outline. I'm doing this off the cuff. So the next thing I have to undermine is this silly notion of conservation of energy as a law. And we have politicized this so-called law of physics, which, of course, is a cover term, of course, for the entropy, and thermodynamics laws, blah, blah, blah. So the Patent Office goes along with it and refuses to even look at anything that claims over unity. So we have to deal with this. So let's deal with it. Conservation of energy is predicated on a presumption that is a hypothesis, not a law. And that presumption is the isolation of energetic systems of energy. It's a hypothesis for the purposes of analysis. It is not a law that any system of energy is isolated. In fact, according to the Wikipedia article on isolated systems, it is known from the fruits of experience, as I quote their use of words, the editors over there. The fruits of experience do not tell us that there is any isolation of any energetic system anywhere in existence. It does not exist. Yet, it proves useful for the purposes of analysis to assume that. And then, as a side note, the article goes on to say, well, maybe the universe is isolated. Well, if that's not a godless science, I don't know what is. Let's just presume it's true that the whole universe is isolated because, hey, that supports my argument. If everything, including the universe, is isolated, there is no way you can have conservation of energy, because conservation of energy is merely useful for the purposes of analysis, because it is predicated on a hypothesis of isolation for the purposes of analysis. It serves no other function whatsoever except to intimidate people by claiming it's a law. So this is hypocrisy among electrical engineers and physicists to claim one thing and then claim something different to the public. This is hypocrisy. All right? So we've covered that. Now, we move on to relativity. This is a beautiful gem. I used to think it was a waste of time because everybody else in my field of studying over unity thinks that relativity is a waste of time, but it's actually very extremely useful, because this is how we explain over unity and free energy. So, we start off with Noether's theorem. Now, it's a waste of time to go look up Noether's theorem on Wikipedia. That article is useless. It just gives you a bunch of math. But if we look up the article on conservation of energy and look at the sub-article, the subtext called Noether's theorem, and by the way, somebody on the internet made a joke and said to me, you know what, Noether's theorem, or Noether, Emily Noether, if you split off her name, her last name, it becomes two words, no ether. Ha ha ha. Fine. But it's not true. It's not true because she actually allows for it. In that subtext of the conservation of energy, it is stated that energy, or that nothing in the universe is dependent upon time per se. Now, this is a statement that intrigued me for many years, and it's not until now that I finally figured it out. We cannot affect time. So all these little gizmos, that mental exercises that Einstein put forward, or whoever it was who put forward the so-called twin paradox, a pair of brothers, one stays behind, another gets in a rocket ship and flies at the speed of light, or nearly so, and they both have watches, and the brother comes back after a certain length of time according to the timepiece of the brother who was left behind. Let's say 70 years, the brother's dead, and the brother who was traveling comes back, finds his dead brother buried, and he visits his grave and compares the watch. He digs up his brother from the grave and looks at his watch and looks at his watch and compares them, and they're different times, let alone the fact that his brother died and he did not age at all noticeably. Well, this is all very well and good, but we can't do that, can we? It would take such a tremendous amount of energy to travel at the speed of light that it's not even a practical experiment. It's just a thought experiment. Yet, I can do it all the time under simulation. How? Because I do not try to change time directly. All right. Now, time from an electrical engineering standpoint, from my perspective, working on simulations alone, breaks down into two parts. There's the overall duration of time that I run a simulation for according to the simulator's point of view. So regardless of how long it takes to compute and calculate and give me the results, from the simulator's point of view, if I run it for a runtime of, let's say, a microsecond, I might get one result because Microcap 12 tries to predict ahead in advance what the results will be. And if it's a mere transient, it'll think the energy is going to infinity when in fact it was just a blip, a burp of tremendous energy and then nothing. Well, Microcap changes its time interval for computing each interval of time. It changes the span of time as it proceeds. It also takes guess estimates when you first start the simulation and will change its methodology of how to go about calculating the results based on its guess estimate in advance, and that's why taking different lengths of time matters. So if I take a long span of time, like 10 million seconds, I'll see things happen that I didn't see if I only ran it for a second. Maybe if I ran it for a second, the circuit in question didn't show any promise, but if I ran it for 10 million seconds, all of a sudden I start to see in the beginning a thermodynamic series of losses to the pre-charged microvolt that I put on a capacitor. And then lo and behold, after maybe 10 or 100,000 seconds, energy starts to build. And they're not sine waves, they are triangle waves, which I read in an electrical engineering webpage. In an inductor, in a coil, triangle waves it is interpreted to mean the non-saturability of the coil. The coil cannot saturate. In other words, if we're just running it conventionally, feeding it all the energy it needs, nothing much will happen. But if we have a negative impedance situation, it'll build to infinite gain. And this is the waveform I look for, are triangle waves. Now, let's get back to relativity. So the overall duration is one way to look at time that I want to affect. But then there's the so-called duty cycle of every cycle of oscillation. I want the current to be opposed to the voltage by 180 degrees, one half cycle, not 179, not 181, not 91, not 89, not 1 degree of separation, positive or negative. It has to be exactly 180 degrees. Some of the time. It doesn't have to be all the time. But if it happens some of the time, that means some of the time this circuit is burping the generation of power, the synthesis of power. From where? From the square root of -1 or from the golden ratio, because those are the two ways that time and space integrate according to Eric Dollard. And when they integrate, we get the possibility for not only the existence of electrical energy or energy in general, but specifically here, the discussion is electrical energy, but we also can create the possibility for the generation of power or its dissolution, disappearing back into where it came from. In the case of square root of -1, it goes back there where it came from. Anywho, relativity. So what I want then is the separation of current from voltage. So the reversal of current per duty cycle, per cycle of oscillation, and the reversal of time, because microcap actually tells me this. If I take a total power, they have these functions called PGT, EG, or it might be some other variety. It might be PST for total power storage, EST for total energy storage, or it might be PDT, total power dissipation, or EDT, total energy dissipation. And these are prejudicial terms. They are simply, they have nothing to do with dissipation or storage, according to over unity. They only have to do, or generation for that matter, they only have to do with generation, storage, or dissipation according to conventional functionality, according to conventional applications of conventional wisdom. But with an over unity, they don't apply. Instead, they become categories of components. And by merely being categories of components, now under the umbrella term of over unity, we have to redefine them. So generators are voltage sources, current sources, which I don't need most of the time, because I'm using a precharged capacitor most of the time. Dissipators are like resistive loads, like diodes and resistors. Well, resistors never generate power, but I can get a diode to generate power, generate negative watts. So see why I have to change the definition of what these categories mean, because dissipation means nothing anymore, except for resistors. But for things like diodes, it does not compute. It doesn't work. And then storage. For storage components, so-called caps and coils, they don't store anymore, because I can get a coil to generate power without the assistance of a prime mover. Without the assistance of a prime mover to feed the coil voltage or to move the coil mechanically through a magnetic field in order to generate current, I don't have to do that. All I have to do is get current to invert itself relative to voltage by 180 degrees some of the time, and then the rest of the time, the caps and coils are operating as storage devices to help accumulate all of this lossless, useless reactive power that, of course, will become useful when it becomes large enough to convert into heat, meeting up with various impedances, positive impedances of various sorts. It'll convert into heat, boil water, run a steam turbine, rotate an electric generator, and we can do away with all the nuclear power plants and coal-fired plants. All of the unnatural ways, the unhealthy, environmentally polluting ways of acid rain and whatnot, of generating electrical power that we don't need to use anymore, because we used the excessive reactive power buildup of so-called useless, lossless energy. Once it becomes large enough, it will convert into heat, and it will not be lossless nor useless anymore. All because it accumulated over time. So the duration of time is necessary in order for that, the reversal of time, aka the reversal of current, becomes useful over a period of time. It could be nanoseconds, could be instantaneously, could be 10 million seconds, but over a duration of time, that reversal of current, also known as reversal of time, will become useful. Now, I got ahead of myself. So, I forgot to mention, microcap will give us, so besides the fact that it chooses the size of the interval, it will also determine its polarity of sign value, positive or negative. And that tells me which direction time is going in. When current gets reversed, time also gets reversed. So whatever happens per cycle of oscillation happens on a grander scale of multiple cycles of oscillation, namely the duration of the runtime to give me reversal of time, not just reversal of current per cycle of oscillation. Now, why is this possible? Because relativity didn't go far enough. When the physicists stole from the electrical engineer the term of, or the subtext to electrical engineering known as electrical reactance and magnetic reactance, namely the square root of -1 and the golden ratio, because the golden ratio takes care of magnetic reactance over unity situations, while the square root of -1 takes care of electrical reactance. When they stole that, just to give you an example of electrical reactance, the factors of capacitance, inductance, and frequency, I can use those factors to create over unity, or I can go over to the magnetic reactance and use the golden ratio to do it, and thus indirectly affect time by reversing current and thus reversing time. And all of these factors of electrical and magnetic reactance are factors of relativity. They give me the ability to manipulate time so that I can get over unity, namely the reversal of time. I can probably get anti-gravity too, but that's a whole other field I've never studied. But it's probably, from historical references, anti-gravity and over unity tend to go hand in hand. They're just two different ways of expressing the same phenomenon. One takes the direction of iron, namely power, and the other takes the direction of aluminum, namely anti-gravity. So it's really two different varieties of magnetism, paramagnetism versus ferromagnetism, anti-gravity versus power. Meanwhile, the properties of diamagnetism exhibited by copper gives us that electrical reactance that we're looking, or the magnetic reactance that we're looking for to manipulate time. So all of these factors that I can manipulate within the field of reactance affecting time, these are factors of relativity. So we can't limit ourselves to the twin paradox situation of a time dilation in order to explain relativity. It's not enough. It's a start. It's a simple, notion, a simple, silly little mental thought experiment, but it goes beyond that. The pragmatic practice of over unity, of time dilation, is predicated on manipulating the factors of electrical and magnetic reactance, which affects our perception of time as a theory. But in real terms, in physical terms, it changes the perception of energy from the point of view of the circuit. It doesn't. In the last analysis, it doesn't matter what we think. What matters is we convince the circuit to change its perception of the energy that we gave it. So if we gave it a microvolt or a microampere amounting to either nanowatts or picowatts, when we give it that scant amount of stimulus to provoke negative impedance in a properly designed circuit, the properly designed circuit will change the circuit's perception of the energy that we gave it. Not right away, sometimes instantaneously, but most of the time over a period of time, over a period of duration, maybe 10 million seconds. It will change its perception of what we gave it, so that even though conservation of energy is upheld all the time, the conservation of perspective never is. When it comes to reactance, when it comes to real power, conservation of energy is always upheld, and the conservation of perspective is always upheld. But when reactance gets into the picture, conservation of perspective falls flat on its face. It breaks down. Meanwhile, conservation of energy keeps singing along, happy as a clam, because it was never impacted, ever. The reason why I say this is because let's go back to time, the perfect example, and move on from the twin paradox example to how we measure speed, miles per hour. If we can change the factor of hour, which miles is measured in terms of to give us acceleration, the consequence of acceleration. When we add 10 more miles per hour to our cruising speed of 50 miles per hour, because we want to pass the vehicle in front of us, so we move to the left-hand lane, to the left of them, because we're sitting right behind this big 18-wheeler that's lugging along very slowly. So we move over to the left-hand lane, we give it some more gas. It's costing us extra energy because that's the way our engine was designed, was based on thermodynamic losses only. It's great for the oil companies, makes them more money. But we had to use that extra energy, regardless of how we got it from, whether from an over-unity device or an under-unity device. We have to apply extra energy to that engine to accelerate. That's already a given. And that energy will give us the extra 10 miles per hour in addition to the 50 miles per hour cruising speed so that we can accelerate and pass the truck in front of us that's lumbering along. Well, we measure that speed of acceleration based on miles per hour, 10 miles extra per hour that we added to our cruising speed. And that speed cannot exist. The miles of that speed, that additional speed, that additional 10 miles of speed cannot exist without being predicated on hours, on time. So if we change time, we change the speed, even though the 10 miles remains the same. If we reverse time, or contract time, dilate time, whatever we do to time will impact the measurement of speed. All because we played around with reactance. That's why I say reactance is relativity. That's why we can safely say that the physicist did not really steal reactance from the electrical engineer. He simply borrowed it for a very long duration. It's been a century now, or over a century, long enough for somebody like me to come along and say, okay, now time to take it back. So now we'll just forget that you stole it from the electrical engineer because you borrowed it and you put a fresh new perspective on it. You contributed to the situation. You did something the electrical engineer couldn't seem to do or didn't do fast enough, and you did it quicker. The physicist did it quicker by renaming reactance relativity and generating a whole bunch of quantum mysticism around it as if it's exclusive to physics when it is not. The electrical engineer has been explaining it all along without realizing it, with the help of Steinmetz, with the help of Oliver Heaviside, and the help of all kinds of notable personages, both dead and still alive, who have contributed to the study of electrical reactance, to the field of the square root of -1 or the field of the golden ratio, as fields worthy of the endeavor of study, because therein lies the magic of making energy seemingly disappear, seemingly appear, out of nowhere, into nowhere, when the nowhere in question, or the ether in question, that is not an absolute reference frame, is the imaginary plane of the square root of -1, or the beautiful set of relationships of the golden ratio. Well, that's a mouthful. I will finish my monologue by saying that 20 years ago I studied the golden ratio. I discovered there's an infinite range, potentially speaking, of the golden ratio, but that infinite range is not practical because you can't solve it, except for the sets of golden ratios that are predicated on the Fermat primes. You know, the 5 Fermat primes, the only Fermat numbers that are primes. Those polynomials in one unknown predicated on that order of polynomial will give us a set of golden ratios for that domain, and the quadratic polynomial that gives us the one that we're familiar with, 1.618, is only one of those 5. Actually, we have to say 6 because the number 1 is the first golden ratio. The side of the equilateral triangle divided by the base gives us the number 1, and that's the first golden ratio right there. So we actually use the second one in the quadratic. So the linear polynomial followed by the quadratic, and then I guess the next one would be, 5 or 17? No, excuse me. Well, 17 is actually divided by, subtract 1, divided by 2. That's the 8th order polynomial, isn't it? Or is it 17? Well, anyway. No, it's the 17th. That's right. No, it's the 17th order polynomial. isn't it? Oh, God. It's been 20 years, so I have it on my website, but anyway, if you're interested. So that's my monologue, my dissertation on overunity, as a predicate to defend why I should be useful to be hired as an associate professor. You guys need help. You need a little freshening up of your subject matter, because the power grid already deals with this because it's large enough that it crops up and they have to deal with it. Or else Steinmetz would not have invented the utilization of the synchronous generators, so-called synchronous condenser, to deal with these anomalies that exist in the power grid because of its largesse, because of its size. And this did occur also in the telegraph industry back in the 1800s, when they spaced out the earth batteries far enough along the transmission line to boost the power. If they spaced them too far, they got the anomaly of overunity from that electric battery, from that earth battery. And if they didn't space it out far enough, or if they didn't include it at all, then the power, if they only had it at the telegraph station, and they had too much distance between stations, then the power would dim, of course, and they wouldn't be able to send the power down the line. And of course, Oliver Heaviside, if you didn't wrap the darn thing in iron, the magnetic field lags behind the electric field, and the signal never manages to reach the destination across the Atlantic. And nowadays, the power grid, they put banks of capacitors in line, in series with the transmission line, to retard the electric field, so that it can keep pace with the magnetic field when the transmission line gets distant enough in space. So they don't have transformers blowing up due to the phase angle between the magnetic and the electric field becoming greater than 90 degrees. Anywho, I've said enough, and if that doesn't get me hired, then probably nothing else will.